Hello everyone, welcome to shiwam'sclasses. In today's lecture, we are going to discuss exercise 3.2, which is part of trigonometry. So in this chapter, we are going to discuss problem 1, 2 and 3 and in further lectures, we'll try to conclude this exercise. So before proceeding to the exercise, let's first understand the concept behind this exercise. So this exercise talks about some values of cos theta, sin theta and cot theta, and they've been given in terms of some numbers, and also it's been given that in which quadrant they lie. So first of all, let's understand what is the concept behind this. So if you remember, we had this kind of quadrant system, and all the trigonometric entities in this quadrant, which is first quadrant, is positive, all positive. All right, in this only sine and of course opposite of cos sine, which is cosec, would be positive, and then in this tan and cot would be positive, and then finally in this one cos and sec would be positive. All right, so this is the concept, right? And now if the values are given in some quadrant, then we got to figure out what entities would be positive and what entities would be negative. All right, so there is an acronym for it, or rather kind of a sentence. Generally people make use of it. The sentence is called add sugar to coffee. All right, so in this one you can see all, and then S stands for sine, T stands for tan, and C stands for cos. So add sugar to coffee is something people remember this rule with. All right, so now once we have talked about rule, let's try to discuss problem number 1. So problem number 1 says cos x is minus 1 by 2 and cos theta is in third quadrant. So I mean, just for our understanding, let's draw the coordinate system as well and then see. So okay, so now cos is here, and cos would be negative, of course, in third quadrant. So what is negative over here? If you trying to draw a line like this and theta like this, so what it tends, essentially cos theta is telling you is that this divided by your hypotenuse, right? So your cos theta here is nothing but, if it is your b and this is your h, so it's b by h, right? And you can see that if it is x-axis, it's y-axis, you can know that x would be negative this side, and that is why b is negative. Alright, so this is how we interpret it, but let's proceed further. You know cos theta, then of course you also know sec theta. So sec theta will be what? Sec theta would be opposite to 1 by cos of x, which is nothing but 1 upon minus 1 by 2, which is nothing but minus 2, right? Now when you know cos theta, you can also know sin theta, because you know this trigonometric identity, which is sin square theta plus cos square theta equals to 1, right? And since you have sin square, you don't have sin square x, but you have cos square x, which is 1 by 2 whole square, and which is here 1, and so it implies that sin square x is nothing but 1 minus 1 by 4, which is nothing but 3 by 4, and with this what you get is sin theta as sin x as square root of 3 by 4, which is nothing but square root of 3 by 2, and it will be plus and minus, right? In third quadrant, since my sign is also negative, and as you can see that since b is negative, and even this p will be negative as well, because it's in the third quadrant, and then here y would be negative as well. So we'll have to take negative values of sin theta. So sin x equals to minus root 3 by 2. This implies cosec theta or cosec x would be opposite to that, which is 1 upon sin x, which implies it is nothing but 2 upon root 3 and minus right? Now coming to the last bit, which is tan theta and cot theta. So tan x is nothing but sin x upon cos x, and we have sin x as minus root 3 by 2, cos x as minus 1 by 2. So this is nothing but root 3. 2 would cancel out and minus minus would cancel out. So and then cot x would be 1 upon tan x, which is nothing but 1 upon root 3. Alright, so we have got all the values. We have got cos x, we have got sec x, we have got sin x, and we have got cosec x, right? So now let's move on to the next problem. So our next problem is this one. Here it is saying sin x equals to 3 by 5 and x lies in second quadrant. Again, just trying to reiterate the point. So if you have this quadrant, so it's here, it's saying in second quadrant. In second quadrant, we know sin theta is positive, right? So now sin x equals to 3 by 5. This implies cosec x equals to 1 upon sin x, which is nothing but 5 by 3, just opposite to that, right? Since we know sin square x plus cos square x equals to 1, this implies cos square x equals to 1 minus sin square x, which implies 1 minus 3 by 5 whole square, which is nothing but 1 minus 9 by 25, which is nothing but 25 minus 9 upon 25. Alright, so cos square x is nothing but 25 minus 9 is 16, so 16 upon 25. So cos x is nothing but square root of 16 upon 25, which is nothing but plus and minus of 4 upon 5. And now we know that in this quadrant cos would be negative. This implies cos x is minus 4 by 5. So this implies sec x is nothing but 1 upon cos x, which is nothing but 1 upon minus 4 by 5, which is nothing but minus 5 by 4. Now coming to the last one, which is tan x. Tan x is what? Sin x upon cos x, right? We are going to discuss problem number 3, 4 and 5 of chapter 3.2. So we had discussed in last lecture as to how to interpret this problem, but we will do it again over here. So first of all, let's draw the coordinate axis and try to read through the problem as well. So let's read the problem. So what is the problem saying over here is that cot x is given as 3 by 4 and x lies in the third quadrant. So this is my first quadrant, this is my second, this is my third, and this is my fourth quadrant, right? In first quadrant, everything, all trigonometric functions will be positive. Here only sin and cosec would be positive. Here tan and cot would be positive, and finally here cos and sec would be positive, right? So we had discussed this, and then maybe we'll have to go through the proof once again just to understand why it is so. But if you look at the coordinate axis, which is x-axis, this is x dash, y-axis, y dash. So you know that y is positive and x is positive in this quadrant, and y is positive and x is negative in this quadrant. X is negative and y is also negative in this quadrant, and x is positive and y is negative in this quadrant. And if you remember the trigonometric and functions, you know that the value of sin theta is nothing but p by h, value of cos theta is nothing but b by h, value of tan theta is nothing but p by b. Alright, so all these values you know,
you know that P, and if you can create a figure like this, if this is your theta, this is your P, and this is your H, you know that P is positive in the first quadrant, P is as well positive in second quadrant, but P would be negative in this quadrant, and similarly your P as well will be negative in this quadrant, and your finally P would be negative, but H would be positive. P would be negative, but P would be positive in this quadrant. So because of this reason only, sin theta is positive here and here, while cos theta is positive here, while tan theta is positive here, because P and P both are negative. So we have discussed this in previous lecture as well. Here as well we have discussed, so now you know that what is the reason that sin, cos and tan are positive or negative in various quadrants. Now try to solve this problem. So we have been given cot x equals to 3 by 4. So what we can get tan x from here, we can get tan x equals to nothing but 1 upon cot x, which is nothing but, you can see it is 3 by 4. So 4 will go up, so it will become 4 by 3. Now we have got cot and tan. We know that another trigonometric identity, which is sec square x minus tan square x equals to 1. Right? Now given this, we know that sec square x equals to 1 plus tan square x. Given this, we know it's 1 plus 4 by 3 whole square, which will be nothing but 1 plus 16 by 9, and it will turn out to be 25 by 9 if you sum it up. Or let me just do it one more step. Let's not skip any step here. So if this is my 9, then 9 will be LCM, and this 9 plus 16 would be 35 by 9. So this implies sec square x equals to 25 by 9. This implies sec x is square root of 25 by 9, which will be nothing but plus and minus of 5 by 3. But since it's given it is in third quadrant, we know that sec theta would be negative in third quadrant, only cot and tan would be positive. So sec x would be nothing but minus 5 by 3, as sec x is negative in third quadrant. Given this, we get cos x equals to 1 upon sin x, which is nothing but 1 upon minus 5 by 3, and we'll get minus 3 by 3. So now we have got sec x, we have got cos x. Now can we get sin x from here? So sin x would be nothing but 1 minus cos square x square root. Why? Since sin square x plus cos square x equals to 1. So this will give me 1 minus cos square x. 1 minus cos square x is nothing but minus 3 by 5 whole square. Alright. Now what you will get here is, you will get 1 minus 9 by 25, which will be again 1 minus 25 minus, rather let's write, take LCM 25 minus 9, which is your 16 by 25, which will be plus and minus of 4 by 5. Again, sin x would be negative in this. Sin x would be negative in this quadrant. So you will take sin x equals to nothing but minus 4 by 5. Given this, you can get cos x equals to 1 upon minus 4 by 5, because it is cos x is nothing but 1 upon sin x. This will give you minus 5 by 4. So we've got all the trigonometric identities. You can see these are my trigonometric identities, right? Now let's go to the next question. Next question is, Again, we got to find out all other trigonometric functions given sec x equal to 13 by 5 and x lies in fourth quadrant. So, just again remember, in other words, what we remember is add sugar to coffee, right? So what is happening over here is sec x is in fourth quadrant. Here cos and sec would be positive, right? So that is why sec x is 13 by 5. So given sec x, we get 13 by 5. So we can get cos x is nothing but 1 upon sec x, which will be nothing but upon 13 by 5, which will be 5 by 13. Now we have got cos, we have got sec. Can we get tan? We know that sec square x minus tan square x is equals to 1. This implies 13 by 5 whole square minus tan square x equals to 1. This gives me tan square x equals to 1 minus. So I'll have to go that way, sec square theta minus tan square theta equals to 1. So then tan square theta will go that side, sec square theta will come this side. So it will be 13 by 5. I have sent tan square x on the other side. So it will be 13 by 5 whole square minus 1. This implies tan square x is equal to 13 will be 169 divided by 25 minus 1. This will be 25 will be LCM. It will be 161 minus 20. Sorry, 169. This is 169 minus 25, which will be 144 upon 55. This will give me tan x equals to the square root of 144 upon 25. So this will give me 12 upon 5 in plus and minus. But we know that tan theta would be negative in fourth quadrant. This will give me tan x equals to minus 12 by 5. Why? Because tan x is negative in fourth quadrant. Now we have got tan x. So can we get cot x? Yes, cot x would be 1 upon tan x. Now 1 upon minus 12 by 5. This will be minus 5 by 12. Coming to sin x. So sin square x plus cos square x equals to 1. This implies sin square x equals to 1 minus cos square x. It will be 1 minus 5 by 13 whole square from here. So it will be 1 minus 25 by 169. 169 would be the LCM. So it will be 169 minus 25. So my sin square x would be 144 divided by 169. This implies sin x would be the square root of 144 upon 169, which will give me plus minus of 12 by 13. But we know that in fourth quadrant sin x is negative. So sin x equals to sin x equals to minus 12 by 13, as sin x is negative in fourth quadrant, right? So now we got sin x. Can we get cosec x? Cosec x is nothing but 1 upon sin x, which will be minus 13 by 12. So we have got all the entities. Now let's move on to the last problem of the day, which will be the fifth problem. Again, I've been given tan x equals to minus 5 by 12 when x lies in second quadrant. So tan x is negative in second quadrant and Quadrant is negative except sine and cosec x, everything else is negative. So you got tan x equals to minus 5 by 8 12. This implies cot x is nothing but 1 upon tan x, which is nothing but 1 upon minus 5 by 12, which is nothing but minus 1 by 5. So you got cot x. Now given tan x, can you get sec theta? So sec square x minus tan square x equals to 1. So sec square x equals to 1 plus tan square x, which is nothing but 1 plus 5 by 12 minus of 5 by 12 whole square. So minus of 5 by 12 whole square, 1 plus minus 5 by 12 whole square will be 25 upon 144, which will come out to be 144 being the LCM, 144 plus 25, which will be 169 upon 144. So this will give me sec x equals to the square root of 169 upon 144, and it will give me plus minus 12, 13 by 12. Now we know that in second quadrant sec x also will be negative. This implies sec x equals to minus of 13 by 12, as sec x is negative in second quadrant. Now we got sec x. Can we get cos x out of this? Yes. Cos x is nothing but 1 upon sec x. So we get 1 upon minus 13 by 12. So we will get minus 12 by 30. Alright. So you can see this is the process we are following. Given tan x, we are getting sec x. Given sec x, we are getting cos x. Given cos x, we are getting sin x. Because we know some of the trigonometric functions. So what is that we get? We get sin square x plus cos square x equals to 1. This gives me sin square x plus minus 12 by 13 whole square equals to 1. Then this gives me sin square x is 1 minus 144 upon 169. If I take 169 as LCM, I get 169 minus 144, right? And this will give me nothing but 25 upon 169. So my sin x is what? My sin is the square root of 25 upon 169, which is plus minus of 5 upon 30. Again, my sin x would be positive in second quadrant, so we will take 5 by 13. Since sin x is positive in second quadrant, right? Now given this, can we get can we get cosec x? Yes. What is my cosec x? Cosec x will be 1 upon sin x, and which will be nothing but 1 upon 5 by 13, and this will give me 13 by 5. Okay, so this is what we had to discuss in 3, 4 and 5.
Hello everyone, welcome to shiwam'sclasses. In today's lecture, we are going to discuss problem number 6 to 10 from the chapter 3rd, and the exercise number is 3.2. So in these problems, we are going to discuss finding out the values of trigonometric functions at various given values of angles, which could be in degrees or in radian. So before proceeding with the solution, let's try to understand some of the basic concepts behind how to solve this problem. Alright, so let's first draw the coordinate axis so that we understand how the angles work. So when you look at the coordinate axis, you know from here to here we have value of theta from 0 to 90 degree or 0 to pi by 2. So from here to this side we will be moving in the positive direction, and our value of theta would be pi by 2 or 90 degree. When we go from here to here, then our values would be pi or 180 degree. When we go from here to here, then the value will be 3 pi by 2 or 270 degree, and finally from here to here it will be 360 degree or 2 pi. Similarly, you can go in the other direction as well and try to get the values. Like here to here it will be minus 90 degree, then from up to here it will be minus 180 degree, and then from here to here it will be minus 270 degrees, and from this side from here to here it will be minus 360 degree. So in this direction the angles are negative. So you know, right, you can actually look at this relation as well. Pi by 2 equals to 90 degree, then pi equals to 180 degree, and then 3 pi by 2 is equals to 270 degree, and then similarly your 2 pi is 180 degree. So if you put it plus and minus, it will be also plus and minus, 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 and plus and minus. Alright. So now you can either go in one direction or another. The third thing which you need to know here is, again, I'm just trying to draw another coordinate axis, that for sine and cos, sine theta and cos theta, the values repeat. What I mean is, the values repeat is like whether you are here or you are taking a full circle and coming here. So whether you are here or you are taking a full circle and coming here, the values will again start rotating. So we know that the values of sine theta and cos theta would be repeating. In some other lecture I will try to explain you how the graphs of sine theta and cos theta would be, but you know that at every 2 pi the values would be repeating, and then for tan theta and cot theta every pi the values will be repeating, right? So we have to make use of these relation and try to see that, right? So we'll take the first problem. This is sine of 765 degree. This is sine of 765 degree. Now we can write this as sine of 360 degree into 2 plus, so 360 degree into 2 will be 720 plus 45 degree. Why did we do that? Because as we discussed, sine theta would be repeating after every 360 degree, right? So we can come back to the same place when we take 2 rotations. So after 2 rotation we will be back to the same place, and then we can go in this direction with 45 degree. So now what we get here is sine, this will give me sine 45 degree. Okay, so this will reduce to sine 45 degree, and you know the sine 45 degrees value is 1 by root 2. So this is the 6th problem. Now let's look at the 7th problem. My 7th problem talks about cosec of minus 1410 degree. Cosec of minus 1410 degrees. So cosec of minus 1410 degree, again we can write it as in 2 ways. What we can do is, first is, let's add something near to this. So for example 360 degree into 2 would be 720 degree, and 720 degrees multiple of 2 would be, this will be my 1440 degrees, right? So I can write this as cosec of, say, I'm just adding this 4 into 360 degree, and then when I do this, this will become 1440 degree, right? I'm just adding this to 1410 degree. So this will give me what? This will give me nothing but cosec of 30 degree, right? Why did I add this? Because we know that after every 360 degree I will be back to the same location. That is why I rotated it by 4 times by 360 degree to come back to the same place. So what I mean is, see, if it is theta this way, right, this is my negative theta. What I can do is, if I add 360 degree to it, what will happen to it is that it will, if I add 360 degree to it is what? I am adding this 360 degree to it, right? This is nothing but this is 360 degree minus theta. I can as well, I can say that, right, minus 3 theta is equal to nothing but 360 degree minus theta, and this will keep happening for as many times I will keep rotating, right? So this is why I did this thing. Now cosec 30 degree is what? 1 upon sin 30 degree. 1 upon sin 30 degree is nothing but 1 upon, I mean, if you remember cosec 30 degree directly, that is fine. If you don't, then you can do this as well. This will be 2, right? Now coming to the third problem, which is 8. This is tan of 19 pi by 3. Tan of 19 pi by 3. Tan of 19 pi by 3. Can I write it as like tan of 6 pi plus pi by 3? Because 6 3s are 18 pi plus pi by 3. So this is what I did. And this is again, every pi is 360 degree, right? You know that? Every pi would be, 2 pi would be 360 degree. So this will be nothing but tan of pi by 3, and we know that tan of pi by 3 would be nothing but root 3. So this would be the answer, right? Now coming to the next problem. The next problem says minus of sine of minus 11 pi by 3, right? Sine of minus 11 pi by 3. Sine of minus 11 pi by 3. Again, can I add 4 pi to it? 4 pi minus 11 pi by 3, which is nothing but, I have just added 2 pi. What I have done is, I have rotated 1 and I have rotated twice. Once you do that, you will be reduced with sine of 12 pi minus 11 pi, 12 pi minus 11 pi by 3, which is nothing but sine of pi by 3, which will be nothing but root 3 by 2, right? Now coming to the last problem. My last problem is part of minus 15 pi by 4. Part of minus 15 pi by 4 would be what? Again, I'll have to add 4 pi over here. 4 pi minus 15 pi by 4, which is nothing but part of pi by 4, which is nothing but 1, right? So in all these problems, you see what I have done. I have added multiple of 2 pi. Every time I have added multiple of 2 pi. You could have also worked on these problems, like for example sine of minus 11 pi by 3. You could have looked at like this also, that it is minus 11 pi by 3 is what? It's like minus 3 pi plus minus minus 2 pi by 3, right? Or I could have written minus of 4 pi plus pi by 3 as well, right? This is what I could have written as well, right? Minus 4 pi is minus 12 pi. So if this is what it was, right? My minus of 11 pi by 3. And I have added minus 4 pi plus, I mean I have not added anything, but I have just said that it would be minus 4 pi plus 11 pi by 3, which means that there will be one time I will come over here, second time also I will come over here, and then I have come over there, I have to move from this side to this side, which is nothing but again it is in this quadrant I am moving in pi by 3 direction, and which is essentially what I have done over here as well. Similarly here as well, minus 14 pi by 15 pi by 4, I could have written minus 4 pi plus pi by 4 as well, right? Which is nothing but again you go 1 pi, you come from here, second pi you come back again over here, and then you have to move in this direction pi by 4. So which is nothing but in this quadrant it is just pi by 4, which is the case as well, right? So this is what we were trying to do in this lecture. I think I have made it clear how to solve it. If you do not get it, please write in the comment section below so that I could answer your queries. Thank you so much.